My name is Jordan Cook. So I'm a data engineer by day for Corteva Agriscience in Des Moines, Iowa. And on the side, I maintain a number of open source Python libraries, including one I'm going to talk about today, which is Request Cache. So this is going to be a talk about basically how to make your Python applications as smart and fast as your browser when it comes to sending HTTP requests. So this is relevant for anyone sending requests in Python, but especially if you're doing something like web scraping or consuming a REST API or another external service. So if you do performance profiling on an application like that, it's almost always going to be IO bound. In other words, the time spent on sending those HTTP requests absolutely dwarfs the time spent on everything else. So how can we make this better? Well, let's take a look at what your browser does. So when you're browsing websites, your browser is chatting back and forth with the server to kind of negotiate how to control caching, how long to cache things, what to cache. And there are quite a few of these headers, but the most fundamental is cache control. So what I'm going to show here, so I'll just hop over to the terminal. I'm going to use HTTP because it's a Python-based HTTP client, seems appropriate. So looking at the GitHub API here. So this is an API endpoint to grab repository information. And here are all the headers that GitHub sends back. So there's a bunch of stuff going on here. A couple of these are relevant for caching. There's a bunch of these headers. The most fundamental is this cache control header, which has these different directives. Most basic is this max age. So this is kind of the most fundamental way a server informs the client how to cache, is just a value in seconds. So this says, keep this in your cache for 60 seconds. And so your browser is automatically going to do that, along with a bunch of other magic. There's multiple layers of caches. But to do that in Python, well, let's take a look at the spec for cache control. Good old RFC 7234. Do you like reading walls of text? If you don't like reading walls of text, there's a handy library that implements all of this for you. It's called Request Cache. So basically, it will kind of do most of the same things that your browser does. So let's kind of take a look at how that works. Let's import session. So if you're so I'm going to focus on the request library. So if you're not familiar, request sessions, that's really best practice to use instead of the one-off kind of get, send methods. It does connection pooling and other stuff. Anyway, if you're familiar with sessions, Request Cache basically provides a drop-in replacement for that called cache session. So you use this to send requests, just basically the same as you would with a regular request session. So I'm going to send that same request. So there's the response info. That's kind of a wall of text. But let me send that again. And so that was actually cached. So I mean, the GitHub API is actually pretty fast to begin with, so you wouldn't notice much of a difference there. But this is especially relevant for like slower or rate limited APIs, which is kind of one of my original motivations for diving down this rabbit hole. So I'm just going to try HTTP bin, which is a tool from the developers of Flask, I think, that kind of simulates REST API endpoints. So here's one that kind of simulates a slow endpoint that with a delay of 2 seconds. So you notice that took a while, and that one was instant. And let's take a look at that object. So it's basically a modified request.response object with some extra caching info, and that actually came from a local SQLite database. So that's just real quick version of the kind of the most basic kind of caching. So there's one more thing I think I have time to go over. So another interesting piece of info that GitHub sends us with this API is this E tag. And what the heck is an E tag? It's kind of like a cache key. So this is a unique value that the server will change when the actual content changes. And how you use that is you send us a conditional request. Your client says, hey, has the thing with this key changed at all? The server can say, yes, here's a new response, or no, it hasn't changed, which saves you the overhead of another request. Your cache will, keep it for those 60 seconds. It'll do a conditional request, so you still save on some request time even after it expires. Calvin, how much time do I have left?
Minus 15 seconds.
Okay, well, I'm done. If you have any more questions, hit me on GitHub or in Slack. I'd be happy to answer any questions you have about this.
That was it.